So we've done the cosine. Do you remember what the ratio is for the cosine?
No.
Sure you do.
No, I don't.
SOHCAHTOA. What's the ratio for this cosine?
Adjacent
Adjacent over hypotenuse. That's right. Okay. What would the sine be? Opposite over hypotenuse. What's the tangent? Opposite over adjacent. So those are important to know. Now, we only use those. We just mentioned this just a minute ago. We only use those when we have what certain type of triangle?
Right triangle.
When you have a right triangle. Okay. You can only use the sine, cosine, and tangent when you have a right triangle. Well, what if you don't have a right triangle and you're given information you need to find a missing side or a missing angle, that kind of thing? So we use one of these. It's the law of cosines. So let me get my notes right here. And let me draw a triangle for you. And you use the law of cosines. Oops. Gotta change my pen settings. There we go. So you use the law of cosines under certain, you can't use it for like every single triangle. Depends on what they give you. All right. Depends on what information they give you. And I'll show when we can use it after I draw the triangle. Okay. All right, so here's just your basic everyday, kind of looks like a, I don't know, it looks like an acute triangle, I guess. And let's do this. I think I switched it up in my notes. I just want to, it doesn't matter. I'll just wing it. A, B, C. So if I call those angles A, B, and C, what would I call this side right here? Little a, and what would I call this side right here? Little c, and then this one, little b. All right. So if I call those angles A, B, and C, that's what I would call those sides, just to make things a little easier, just so we can compare them to each other and that kind of thing. Now they do a proof, or they show you basically where the law of cosines comes from. We just don't have enough time left in the year, even in this class period, to do that. It's kind of interesting to see where this comes from, but I'm just going to show you what they concluded, okay? What they came up with. Now, well, a lot of math books, you can set it up three ways. You know how we did that side angle side area thing, and we said it's 1/2 like BC sine of A, and then we could have said, what, AC sine of B, and then we could have said, I don't know, what's the other one I missed? BC? No, what did I miss? AC sine of B. Did I say that already? Anyway, you get the idea, right? Whatever's missing. So it's kind of the same way with this. Normally, a book, if you look in a math book, normally they would do the C first, okay? Normally, but we'll do all three of them just to show you. So I'll just show you what you normally see. So this is little c. I know a big C and a little c kind of look the same, but that's a little c right there, all right? So that means this side right there, and we're going to square it. So it actually starts off being very, very similar to the Pythagorean theorem, except we put the c first. Instead of a squared plus b squared equals c squared, we're going to write what? C squared equals what? A squared plus b squared. But there's a little bit more to it. Okay, we just tag on a little bit of extra stuff. All right. So if you can remember the little extra stuff, just remember that the law of cosines is very, very similar to the Pythagorean theorem, except we get a little bit of extra stuff at the end. All right. So here it is. It's 2 times whatever these two are right here. All right. And then you put AB. See that? So whatever these two, you multiply the A and the B times the 2. And then here's the law of cosines. It's cosine of whatever this angle is, whatever's opposite this side right here. So what would this angle be? What angle is opposite side C? Right, angle C. It's big C. Okay, the angle's always the big one, okay? So that's big C, this is little c. And there it is. That's your law of cosines. It's a minus. So the beginning of it's pretty easy to remember. It's just Pythagorean theorem, right? The c being first. So we go c squared equals a squared plus b squared. Then you just have to remember this. Minus 2. Okay, that might be a little different. And then you take AB. How do I know it's not AC? Well, I take this one and multiply them together. And then I put the cosine of whatever is opposite this side on the end. Okay, do you see that? So this side right here is by itself, and it goes with this angle right here. So they go together. Make sense? You got the C on the outside, the little c on the outside, and you've got this angle C on the outside right here. So whatever's here is going to be here. You got it? Let's, we could write it. I'm going to put or. We could write it with the A first if we wanted to. So let's see if we could write it like that. A lot of times, I don't worry about memorizing these other two. I'm just doing it because this book does it, and a lot of books do it. But this is the main one that I would just remember, all right? I would remember this because this looks like Pythagorean theorem, right? And then with just that little bit of extra stuff tagged on the end, right? But I will show you this. So if I wanted to write it with the A outside of here, then what would these two be? Right, it would be the B squared plus the C squared. It's just the other two, right? Does that make sense? So if I put A out here, I'll put the B and the C right here. Now, what do I write? What's the rest of it? Minus 2. And then what do I put? Right, BC. I take those two right there, and I multiply them together. And then it's the cosine of what? Of A. Remember, the angle is opposite this side right here. So you could write it like that. So that'd be another way to remember it. Again, you don't have to memorize all three of these. This one right here is the one that I usually just think of all the time. When I think of law of cosines, I think of this right here. My guess is, I haven't done it, but if you Google what is the law of cosines, my guess is they'll probably write it like that. Let's just Google it really quick. Law of cosines. And yeah, there's one right there. Yeah, the very first one, they put the C squared equals A squared plus B squared minus 2AB cosine of C. It just depends. All right, let's do one more. Or, so I put a C first, put the A first. What's the next one? So you should be able to do this one on your own. I'll give you 10 seconds. Ready? Go. Write it down. Write the next one with B squared. Fill in the rest of it and see if you get it right. Got 5 seconds left. Oh, got that off? You got that off? Just get it yesterday? Taken off yesterday? Oh, did you? Right. But that's good at least. Got the cast off. All right, so what did you write down? B squared equals what? A squared plus, well, not yet. A squared plus what? C squared. Now, minus 2 what? AC, cosine, not cos. It's cosine of what? Angle B. Did you write that down like that?
Yep, exactly.
All right, good. Yeah, it's not too hard, is it? Now, how do we use it? Well, I'm glad you asked. Let's put a triangle. Let's do an example. Example 1. Example 1. This is in the book. It's pretty straightforward. The second example we do, hopefully we'll have time. Let's try to go through this pretty quick then. Whoops. What I want to do there. Okay. Let's do this. Just trying to make it look like the triangle in the book. Kind of looks like that. Not exactly, but it's close enough. All right, so this angle right here, they give you is 57 degrees. They give you this, and they give you this, and they ask you, we'll call it C. They don't actually label it C in the book, but I will. All right? And that's all they tell you. And what you have to do is you got to solve for C. All right? Well, this is perfectly set up for you to use the law of cosines. Because what do we know? I'm trying to find side C, correct? Do I know angle C? Because I got to take the cosine of it, right? Do I know angle C? Why? Why is this angle C? Because it's opposite this, okay? So the ones on the outside have to be the opposite of each other, okay? So if this is going to be C, this has got to be angle C because they're opposite each other. Agreed? So I could put C right there if I wanted to, capital C. So if this is side C, what are the other two sides? A and B. It doesn't matter which one's A, it doesn't matter which one's B. All right? So is it set up for us to use the law of cosines? Absolutely. Okay, this is perfect. This is like the easiest style of law of cosines that you're going to do when you have a situation like this, okay? So let's do it. Let's write it down first. So C squared equals A squared plus B squared minus 2AB cosine of angle C. All right, something you got to memorize. I mean, in math, you just have to memorize some things, okay? I will not give this to you. You got to know it, all right? Yeah, because that's what we said. We said this 57 is, if this is opposite 57, this has to be angle C if I'm going to use my formula like this. So do I know side C? No. So that's what I'm solving for, right? So that's what I'm going to get by itself. Equals A squared. What's the A squared? Doesn't matter. Yeah, let's just use the 6. Plus what? 9 squared minus 2 times what? 6 times 9 times the cosine of angle C. What's angle C? It's 57 degrees. That was the easy part. The hardest part about doing this problem is putting it into the calculator. All right, so let's get the calculator out. Well, let me show you. Let's see. Oh, what I got to go to mode, don't I? Go to mode. Got to do this every time on my calculator. Put it in degrees. Now, normally I wouldn't have to put it in degrees unless I'm doing what with this calculator? Using sine, cosine, tangent, and all that kind of thing, okay? If I was just adding stuff up or multiplying stuff together, I wouldn't have to do that. I would just do it straight up. So here's the key. I'm gonna put something in here. Let's make this a different color, yellow. Here's the key. What I would do on the calculator is this. I put a bracket right here, but on the calculator it doesn't have a bracket, it's got a parentheses. So I'd put a parentheses right here, and then I'd close this parentheses, and then I'd hit enter, okay? So if I wanted to put this in the calculator, by the way, I still didn't quite put everything in that I'm going to put in the calculator. This is C squared, so how am I going to get C by itself? Take the square root. So technically, I'm taking the square root of all this stuff, okay, to get C by itself. Do you agree with that? Yep. All right, so let's put some stuff in here. Hopefully we get it right. You got to practice this on your calculator, I'm telling you, because this is the hardest part. This is harder than setting it up and putting the numbers in, all right? So let's put square root. So in this calculator, I'm going to put square root, okay? And then I'm going to go 6 squared, so 6 squared plus 9 squared minus, now here's the key. Do you see that yellow bracket right there? What am I going to put on the calculator? A parentheses. It's very important that you do that because you're subtracting everything in that parentheses. Okay? Everybody see that? So it's important that you put a parentheses right there. Now you can just write the rest of it. Minus what? 2 times 6 times 9. And then you can just put cosine of 57. Cosine 57. Now, what am I going to have to do after the 57? Yeah. Now, look, I'm going to put that one. See that first parentheses after the 7? That just closes the 57. But now I want to put another parentheses to close that whole bracket. Okay? Are you practicing this on your calculator? Yeah. You should be putting it in. Okay? So, I believe, well, you know what? I may have to put another parentheses because of this right here. I'm not sure. Let's just see if I don't put the parentheses. Let's see what happens. Yeah, it still works. Yep, so we don't have to put that other parentheses right there. And that's your answer. Okay, that's what C is equal to. That's what C is equal to. So if you followed my steps on the calculator, you should have gotten this. And that is what the answer is. So it's approximately, remember, it's a decimal. See how the decimal keeps going? So it's approximately 7.6. And that's what they asked for. Oh, I wish I had like 5 more minutes than I do. That's something you just have to practice, okay? I showed it to you. So, oops, daisy. Let's do that.
Students of health tech experience going to be in the sanctuary. Thank you.
Let's do this. Oh, gosh. I hate being short on time. I shouldn't have taken so much time doing the homework. Hey, we're not finished. Why are we packing up? It sounds like we're packing up. I can just tell by the sound of it. Look at this. This is 78 degrees. This is 5. This is 6. I'm going to skip a step here, but you need to do the step. Everybody watch. This is C. This is A. This is B. This problem doesn't just say solve for C. It says solve the triangle. Solve triangle ABC. All right? Well, what's the one thing I can find right now? I can find C, can't I? So I do exactly what I just did a second ago. I'm not going to do the work just because of time. So if you solve for C, it's 7.0. It actually rounds to 0.0, okay? It's approximately 7.0. All right? So that's what this is. We'll just put a 7 right there. Now, here's the tricky part to the law of cosines. What I need to do is solve for A and B. Right? So I need a way to solve for A and B. So let's do this. Let's solve for A. I'm going to set it up for you. So if I solve for A, this is little a, isn't it? This is little b, and that's little c. So let's solve for A. So that means A squared, I'm going to go A squared equals what? B squared, plus C squared minus 2BC cosine of what? A. Whoops, I forgot the other C in there for cosine. Cosine of A. So let's put the numbers in. So I could put 5 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of angle A. Don't know what angle A is. All right, the bell's going to ring any second, so just hang on just for like 30 seconds after the bell, okay? So watch what we're going to do. We need to get A by itself, all right? We need to get A by itself. So what I'm going to do is this. Do you see how you got this minus all this stuff over here? What I'm going to do is I'm going to put it over on the other side so it's not minus. So I do that just by adding, right? And that's actually, we can just see that in our head. So 2 times 6 times 7 times the cosine of A. Now, I put this stuff over on the left-hand side. What am I going to have to do with that 5 squared? Put it over here on the right-hand side, so I'll minus it. So what's already over there? 6 squared plus 7 squared. This is just basic algebra. It looks a little weirder because you've got all this junk right here. But that's what I did. You see it? I just flip-flopped it. I took this, put it on the left-hand side, took the 5 squared, put it on the right-hand side. Now, that makes things a lot easier for us. Now, watch. I need to get A by itself. So first thing I'm going to do is get rid of the 2 times 6 times 7. How do I get rid of the 2 times 6 times 7? Divide it by what? 2 times 6 times 7. All right? And then I have the cosine of A is equal to this. We've done this before. How do I get A by itself? How do I get rid of that cosine? I take the inverse cosine and watch of all of this. Now, I basically have the problem solved. It's just a matter of doing what? Putting it into the calculator. I'll tell you what the answer is. I want you to try it. Why are we leaving? I said already that I don't want you to leave until I finish this. So it's 44.6 degrees. So it looks pretty simple, but you need to put that in your calculator, take the inverse cosine, and get this, okay? You've got your homework on the lesson plans. It's 1 to 6. It's numbers 1 through 6. And it's section, whatever it is, 12.6. That's your homework right there. Okay, now you can go.